Hey, we are privileged to have Spencer Allen here. As you can see, an overview of creation science he's going to discuss with us. So I hope you enjoy. It's being recorded. If you want to record it, how much will it cost?
Less than $100.
Okay, here it is. Okay, Spencer, I'm going to give it to you.
Right. Well, it's good to be here with you all today. Like you said, we're talking about an overview of creation science. I just completed my first year at Cedarville University. Some of you may know. And Cedarville they have one of the best geology programs of any Christian school in the entire nation. And so after my first year there, I was just really excited about a lot of the things that I learned and seen. And the degree that I'm getting is very similar to an apologetics degree. And so I just feel like coming here today and presenting on this would be a great benefit for some of you to be able to hear about what the best scientists in the creation field are learning today, what they're studying. A couple of disclaimers: I'm not an expert. I know myself pretty well so far, but I've only been doing this for a year, so I don't know everything that there is to know. So, and also I want to try to give you guys an opportunity to do questions, which we'll try to do at the end, so I can get through it. I don't want to use the whole hour, but I can get blabbling on for a lot about this stuff, so I'll try to keep it quick. So yeah, questions at the end. I would love to talk with you guys. I'll be here up until 10, and then after church, I would love to talk if anybody has any questions. Basically, though, I might not be able to answer some of them. I'll try, but I don't know everything there is to know. Most of the time, I just defer to my professors and the smart people who know.
Could you speak louder, please?
Oh, yeah,
Thank
of
you.
course. So, yeah, most of the time if I don't know something, I can defer you to a resource that would be a better help than me. So we just want to talk about creation science, which is a very broad, interdisciplinary topic. And there's so many different areas that we could go with this. And I just wanted to give almost an overview of history according to the modern young earth creationist view. And so today's purpose, and this is really the driving reason why I decided to come here today, is to recognize that Christians do not have to run from science. And so I think that we're in a world where the majority of, though I think it is exaggerated how much of a majority it is, but the majority of science is not going to sit here and take this Bible and say this thing is true. And so we have a tendency to run away, I think, and especially the younger people in schools are taught to not look to it as definitive, absolute truth in some of the more historical settings, and so we run away from that. And my thing here today is we don't have to run from science. We don't have to try to fit Christianity into the new research. We can actually do our own research and our own work and discover how the Bible can be examined ourselves. And so this is just a picture of Time Magazine, God versus Science, which I'm sure some of you have heard. Just kind of the broad idea of God versus science, or creation versus evolution, and these big sort of contradictory, how these are almost against each other in our world today. And the question always is, well, who wins? And for me, I don't think that it's about who wins on either side of these. I don't think that God is versus science, and I don't think that creation and evolution are directly against each other, which is going to be interesting when we get into some of that later. I think that it's much more complex than two sort of simple ideas just clashing with each other. It's sort of theories being laid out. Particularly God versus science isn't a simple idea. God uses science. God created science, and He allows us to do science. And so it's not something that's contradictory. They're together. There's a unison there, and there's something that we can examine. And so that's what we're going to talk about a little bit, is this unison. And I want to start just a little bit of philosophy here on creationism, and we'll clarify that in a moment. But one of the things that we do as creation scientists, and I've only done for a little time, but the great creation scientists have been doing is, that's just sort of something for you to understand here, is we tend not to use supernatural power when we're talking about creation science. And that sounds a little bit weird to say, like, we're going to take a look at today things like creation or the flood or dinosaurs. You'll love to talk about dinosaurs and things like that. And we don't like to use in creation science supernatural power to explain things. And that's not to say that God couldn't, that it's not to say he doesn't have the power to supernaturally do things. It's just that we have no way as scientists to be able to confirm whether or not he's done that. And so we tend to say the assumption of no supernatural engagement when we're trying to explain some of these things, because if God just spoke and something happened, then there's going to be not a ton of scientific evidence for that. He just simply made it happen because he's powerful enough to do that. And we're not really going to be able to do that. And so unless we have eyewitness, which is why we put the Bible here, which is where we see supernatural things happen, particularly like Jesus' miracles are a great example. We have eyewitness of things going where God just makes them happen. But whenever we're trying to examine things that the Bible doesn't expressly tell us, we like to try and see how can we find a way to see how God has used science to sort of allow things to happen. I don't want to say allow things to happen. I think that we have this idea that God created things and he guides them so much. And I almost like the idea, and I've heard a lot of great scientists, creation scientists, talk about how God is so smart and so brilliant and so much better than all of this that he doesn't need to guide it. He created it at the beginning and sets it into motion, and the science just takes care of itself. I've heard this philosophy before, sort of, all of us have a DNA and the genetics that make us up. And it's not that God has to sit there when we're conceived in the womb and create our DNA then. It's that he was so good that whenever he made Adam and Eve's DNA, from that point on, the DNA just worked and fit everywhere so that all people from all time going on there would get the right genetics that they needed to fulfill what he had for them to fulfill. And so it's almost more attesting to the power of God to say, hey, he's using science. He's not just almost doing the easy way of just making it happen. He's literally created something so intricate that it works on its own, and he doesn't have to force it into his own thing. It just happens. So that's why we don't work towards supernatural things, even though there certainly are. Clarification of terms here. I just want to mention this briefly. I say the term creationist. There are different types of creationists throughout the world. I myself personally consider myself a young earth creationist, so I believe in a young earth and that God created the earth probably about 6,500 years ago. And that's a pretty prevailing view, particularly in Christian Science, which is obviously what we're talking about today. And I had this other term here, conventional, and that's sort of what you would hear used as evolutionist or long age of earth, sort of the modern mainstream sort of science. And I don't like to use the term evolutionist because I think it's sort of been used in Christian circles as a very degrading, almost like taking your finger, just poking someone in the eye sort of term. I've actually read a few different papers kind of by conventional scientists, as I would call them, writing about creation and young earth creationist work, and they often will say that people will call, I suppose, it evolutionists in quotations, and you can feel that they feel kind of attacked by this sort of, like, we're almost degrading them as lesser scientists because they don't listen to our religion or whatever. And that's not to say they haven't done the same thing to creationists themselves. I mean, some of the papers on creationist work are absolutely scathing criticisms and just calling it blatant non-science, which is not true. But the point is, we don't have to make this such an attacking sort of language, and so I like to use conventional, and a lot of my professors do as well, just to sort of loosen. It's not a battle. We're just looking at facts here. We're looking at data and seeing how we can interpret it. It's not life and death battle. Some resources here. I have these two books here, The Case for a Creator by Lee Strobel and The New Creationism by Paul Gardner. These are two great resources that I would suggest reading up on this stuff yourself. The Case for a Creator is Lee Strobel, so if you've ever read The Case for Christ, this is very similar. It's just a more scientific approach, sort of, instead of examining scientifically and journalistically the life of Christ. This is examining is there a creator, and some of these questions we're going to be asking today. And I would really suggest that. I think anyone can read that, honestly. The New Creationism is a much more scientist-heavy book. Paul Gardner himself is a pretty big name creationist scientist who's done some really significant work in the last 20 years. And so he's written this book, and I think it's fantastic. We read it in my first semester intro to physical geology class. I think it's a fantastic book, but not for the not interested in some heavy science people. It's pretty heavy duty. So those are great resources, and right here as well, I would honestly suggest taking a picture of this if you're really interested. These are some of the main creation scientists that are writing and researching for the papers that I've read and that are the pioneers in a lot of things I'll be speaking on. The asterisk is by John Whitmore. Dr. John Whitmore is the senior professor of geology at Cedarville, so he's my professor. He also he's done some good work in the last 20 or so years. But these are the big names in the creation field that have really had the biggest breakthroughs. And there's a couple of them on here that we're going to get into some of their work here in a minute that have just had some astounding discoveries. And so to start into creation itself, we've got the two key creationist events that really shape the whole of everything. And so we've got creation and the flood, and these are just two super important events in creation history. Obviously, I've drawn this graph here. I don't know if you can see it, it's not super clear, but this is sort of a representative time according to the young Earth creationist model. We'll get to why I think that the Earth is young and why I think that it was 6 little days of creation. But this graph sort of shows according to that this time scale where these major events are. So you have creation here at the starting point, and then you've got the flood about 2,000 years in, and then about 2,000 years after the flood you've got Jesus, and then about 2,000 years later you've got us. And so this sort of timeline works in, and that's why these two events are so important, is because this right here, obviously creation, when you create something, I mean that's going to be a ton of geology and science to explore, and then the flood itself is, whenever I like to say what really got me into this was sophomore year in high school. I was reading the flood account, and you come across the fountains of the great deep opened up, and to me that was just like, well, that's geology, that's not like just rain, that's something more. And that's what got me thinking a lot about this. And we're going to see how that is absolutely true, how geology has a massive role in the flood itself. And so I just wanted to get into Genesis itself a little bit here and read some of the things that are shaping the way that we're doing our research in some of these categories. So we have Genesis 1:1. In the beginning, God created the heavens and the earth. And so that's there, and that's pretty simple. And then it goes on to talk about the literal days. It says in Genesis 1:3, God said, "Let there be light," and there was light. God saw that the light was good, and he separated the light from the darkness. God called the light day, and the darkness he called night. And there was evening, and there was morning, the first day. And that itself is just a fantastic example of it was a little day, it was a night and a morning, and that's whenever it happened. And then it goes on and reads through the next 6 days, which I won't read all through, but we know how it works out there. And then into almost, I don't want to say the more important part, but the more part we can examine better with science is the flood account. And so there's a couple key things in here that I wanted to read. And so I'm just going to start in Genesis chapter 6, verse 11, and read through for a bit here. Now the earth was corrupt in God's sight and was full of violence. God saw how corrupt the earth had become, for all the people on earth had corrupted their ways. So God said to Noah, "I'm going to put an end to all people, for the earth is filled with violence because of them. I am surely going to destroy both them and the earth. So make yourself an ark of cypress wood, make rooms in it, and coat it with pitch inside and out. This is how you are to build the ark." Then he goes on to name some dimensions. "Make a roof for it, leaving below the roof an opening 1 cubit high all around. Put a door in the side of the ark and make lower, middle, and upper decks. I'm going to bring floodwaters on all of the earth to destroy all life under the heavens, every creature that has the breath of life in it. Everything on earth will perish. But I will establish my covenant with you, and you will enter the ark, you and your sons and your wife and your sons' wives with you. You are to bring into the ark 2 of all living creatures, male and female, to keep them alive with you. 2 of every kind of bird, of every kind of animal, and of every kind of creature that moves along the ground will come to you to be kept alive. You are to take every kind of food that is to be eaten and stored away as food for you and for them." And it says Noah did everything just as God commanded. And then we're going to move over to chapter 7, verse 6. Where it says, "Noah was 600 years old when the floodwaters came on the earth. And Noah and his sons and his wife and his sons' wives entered the ark to escape the waters of the flood. Pairs of clean and unclean animals, of birds and of all creatures that move along the ground, male and female, came to Noah and entered the ark as God had commanded Noah. And after the 7 days, the flood waters came on the earth. In the 600th year of Noah's life, on the 17th day of the second month, on that day, all the springs of the great deep burst forth, and the floodgates of heaven were opened, and rain fell on the earth 40 days and 40 nights. On that very day, Noah and his sons, Shem, Ham, and Japheth, together with his wife and the wives of his 3 sons, entered the ark. They had with them every wild animal according to its kind, all livestock according to their kind, every creature that moves along the ground according to its kind, every bird according to its kind, everything with wings. Pairs of all creatures that have the breath of life in them came to Noah and entered the ark. The animals going in were male and female of every living thing, as God had commanded Noah. Then the Lord shut them in. And then it goes on to just say they were in there for a long time, which is a whole year. And so that's what Genesis itself literally says. And so we're going to get into the research that's been done to dig into what those pages really mean for us and what science can say about them. And so we're just going to go back to creation itself in the literal 6 days. Cedarville is a very, very aggressive literal 6-day school. And whenever I came there, I didn't know that. I didn't do a ton of research on their program, if I'm being honest. So I didn't know what I was getting into, and I didn't really know what they would be teaching at all. When I was going in there, I kind of assumed, just felt in myself that this is probably where it would lead. But not where the school would be, but where I personally thought things actually stood, that God had used 6 literal days. And when I got there, I learned a lot of things that really confirmed that. And so I want to talk about these 3 things that we have up here: gap theory, day-age theory, and theistic evolution. Some of you may have heard of them or been around them, or some of you might actually believe them. And so the first thing there is gap theory. And this is these 3 theories, let me just give a brief sort of synopsis, are essentially kind of things that have happened in the last 100 years or so. As you know, we're going to hear Charles Darwin's name mentioned, and all of this new science has come out about the origin of Earth. And these 3 things right here are really theories that have been created to say, well, how can we as Christians fit this new data that we're finding into our own Bible, and how can we sort of almost explain it away? And that's why I don't like these 3 theories, is because I think that they do a decent job scientifically, but they're essentially just trying to find a way to, how can we just sort of say, oh, we've been beaten by the scientists, we just have to fit their data into our own thing. And so gap theory is essentially the idea that somewhere in between the first and second day, or one of those days, there's a large gap of time that's represented, where God creates the earth, and that the Bible is sort of being figurative, and that actually there's a large span of time where the earth itself actually goes through the 4.5 billion years that's proposed by conventional scientists, and that it creates itself sort of, and that God just sort of pushes it on, and then we get to the rest of the creation, and things sort of go on their natural course, and then the Bible just continues from there. And day-age theory is another really good one. I like this the most of probably the 3, but I still don't like it. And what day-age theory is essentially saying is, you know, I believe it's somewhere in Proverbs or Psalms where it says a day is like 1,000 years to the Lord. And so what this has done is taken the word day in the creation account and said, well, actually, you know, we don't know how long a day is to God, so maybe it was 1 billion years is a day to God. And that's what its day-age is talking about. It's saying, well, those 6 days of creation are actually millions and billions of years of time represented to be able to give us what the scientists are saying, but at the same time this creation thing. And theistic evolution is probably the least sticking to the text of the 3, and it's essentially saying, you know, God has guided theistically, like I was talking about, almost supernaturally, evolution throughout its course, and that sort of the scientists are right in that it's just sort of God has guided it, and then the Bible just sort of picks up, and that almost kind of disregards the Genesis 1 text and Genesis 2 text, sort of is just figurative language, sort of. And so getting into that, these are 3 really big names. You probably recognize Charles Darwin up there. You might not have heard of the other 2. And these 3 names, James Hutton, Charles Lyell, and Charles Darwin, are so important in understanding sort of the origin of why we had to start coming up with these theories I just mentioned. James Hutton was a Scottish scientist in the late 1700s and early 1800s, and what he started doing and what he proposed was he was sitting in front of a rock that I'll show later, actually, I use as a picture, and he was thinking about how he saw the earth moving around him, and he said, well, we see sediment building up and we see rivers eroding streams, and he thought, well, what if Earth has been around for a long time and these processes have been going on for a long time and building up the things around them. And he coined that idea of uniformitarianism, which you might have heard of and we'll definitely talk about. And so for him, uniformitarianism is the idea that the present is key to the past. And so what we presently observe has been happening for time. And so Hutton essentially produces this paper, Theory on the Earth, and it proposes an older Earth, nowhere near what we're at now. He was in the hundreds of thousands of years range. He was nowhere close to what we are now. But he started proposing the idea of an older Earth, which is something that just simply hadn't been done in history up until that time, because most of the people in the world were just, you had some form of religion where some god or being had created your world and you were placed in it or given it. And so people weren't trying to use science to explain these things until he starts proposing this old Earth. And then Charles Lyell was an English scientist. In the 1850s, he wrote The Principles of Geology, which is actually a 3-volume book, one of the most influential science books ever, honestly. And what Principles of Geology discussed was it took Lyell's, it took Hutton's idea of uniformitarianism and really grew it, and he did a lot more actual research and a lot more actual geology and study. And what he found, and essentially what he started to claim was, well, this guy's right, the Earth has been around for a really long time, and that science can show this, and that he started to propose millions of years and move this theory on. And what a lot of people don't realize is when Charles Darwin began On the Origin of Species and went on his voyage, he had read these 2 previous things and had started to get this idea of lots of time. And so whenever he went down to, I think the Galapagos Islands finches is probably the best example of, and started seeing speciation and small examples of some minimal evolution in animals, beak change specifically in finches, he started to think the same way Hutton did and say, well, if animals are changing slowly like this, and we have this time proposed by these other 2, well, what if over time the same thing has happened to animals? And so that's where the entire idea came from, is these 3 guys right here basically just kind of triple punched, and all of a sudden, 200 years ago, out of nowhere, for the first time, we've got science trying to say, well, the Earth is actually old, and things have evolved, and all the religion stuff is just not right. And so that's a big thing, and that was lead us to, it's all about time. All 3 of those things are all about time. They're not about current data, they're about time. And so, like I said, uniformitarianism is the idea of the present is the key to the past. The second idea here, catastrophism, is in direct contrast to uniformitarianism. And this is the idea that sudden moments of extreme change are what kind of shape the world around us. And this is the idea that most of the world had believed for a long time, right? Like if you're a Jewish person for most of history, or a Christian or Muslim, you've got this idea of creation, and that sudden change, and maybe the flood would be an example of sudden catastrophism, or a massive earthquake, whereas uniformitarianism is much more gradual change. And so the whole key here is it's all about time. All of this new sort of conventional data is all about there's a lot of time here to be represented. And so the question that we've got to start answering, this is the first real science we're going to look at, is the Earth old? Can we find evidence that the Earth really is old? Are these people right? And so the first thing that I want to talk about, that I learned a lot about this year, that I think is fantastic, is radioactive dating, and just how simply wrong it is. And so radioactive dating, you've probably heard of. Essentially, atoms have different isotopes, and so they have different types of atoms, if that makes sense. Like, you've probably heard of carbon. Carbon is an atom. It has 3 or 4, I think it's 3, base structures. And so with radioactive decay, what can happen is these structures can change throughout time, and they decay. And this is a big deal for science when we can use in dating, because these decay rates happen at a fixed rate. And so what we do in modern time with potassium-argon dating, which is the KR dating there, which is what we use for rocks, and carbon dating, which is you've probably heard of for living things, those 2 things are essentially taking an organism and looking at the ratio of these isotopes in them and saying, well, if we look at what this ratio is now, and it's been changing from this original starting point down to here to this place it is now, we can try to figure out how old that thing is. And that sounds in theory like a great thing, but it's really terribly wrong for 2 reasons. The first being that, like I just said, it completely assumes where the starting point is. And so one of the things I read about with carbon dating that was very funny is there's a Viking settlement in Iceland that we study. This is a really weird example, but I read about this. where they have documentation, historical written account of, in the 800s, like 800 AD, there was a settlement of Vikings occurring in Iceland. And when we carbon dated some of the things that we had found to try to get a better clue of where they came from, there was massive discrepancy because the carbon dating put them about 100 years older than we've written account knew they were. And they did a ton of research and essentially found that these people had less carbon in their diet than people on land masses did because they ate so much fish. And so that simple change in the starting point threw off the entire carbon dating process. And when you apply that to millions of years, it makes sense that those simple changes from the starting point could throw the entire thing off. And the second thing is Robert Gentry is not necessarily a creation scientist, but he did some work in the 1971, I believe is when this book was published. And these right here are radio halos. So those are they're microscopic. You see that in the microscope. We actually did this in class. We found some of these. These are little kind of circles. They're called radio halos that form in mica crystals and granite rock, which is scientific, but basically granite is a volcanic rock. And this is really interesting data, and it doesn't look like it would be, but here's why. These radio halos are actually formed by essentially uranium-238. So an isotope of uranium is actually, a lot of it is built up in a zircon crystal in the middle of this structure. And what happens is all that radioactive decay over time that's going through this is actually scarring this rock here, these crystals, and causing these halos to be formed. And this doesn't seem like a big deal, but it's a huge deal for creation scientists because it essentially proves that radioactive decay rates haven't been at the same time throughout time. Mica is a crystal that forms in granite, and granite is volcanic rock, so it's magma that's cooling and crystallizing. And these mica crystals only start forming once you get to 150 degrees Celsius and below, which sounds like a lot to us, but 150 degrees Celsius in magma terms is really not that warm at all. It's very cool. It's almost done cooling and hardening at that point. And so there's some debate on how long granite cools. There's other implication of it, and so creation scientists have their own opinion. We have a much shorter time span for how quick granite can cool, and conventional have a much larger. But regardless of who you are, the absolute maximum you're going to claim a granite rock would take to cool from 150 degrees Celsius is going to be about 6 weeks at absolute most. And so that means that the millions of radioactive decay particles that would have to go out to form these happened in only 6 weeks, which is unbelievable for something like uranium to do, which takes the half-life is 4.5 billion years old. So for this much to happen, there had to be billions of years of this radioactive decay happening here. But we know that it must have happened in only at least, at the maximum, 6 weeks. And so that essentially proves that at some point in Earth history, these radioactive rates, which we use to date things, have been different, which would completely change any timeline that we're trying to use them for. So that's great evidence of how the Earth can be young. Second thing is dinosaurs here. This second picture looks like just a blob and just kind of a tissue mass. This is actually live tissue that we found inside of a Tyrannosaurus fossil in its leg bone. We found live tissue inside of it, which this is not a creation research thing. There was a conventional scientist, a paleontologist about 25 years ago who was looking through a Tyrannosaurus rex femur to do some research and found live tissue inside of it, which if the Earth dinosaurs are supposedly have gone extinct 65 million years ago, that tissue is going to be decayed for so long since then. There's no way that it would have existed in that dinosaur femur still, and so that's massive evidence that the Earth is done. And the last thing is the uniformitarianism itself. So ocean salt acclimation rates. I believe it was Steve Austin who did some research on this, and what he looked at was, if you didn't know, the Earth or the oceans of Earth are actually getting saltier. They actually gain salt each year. They gain an increase in saltiness and sedimentation as it comes in. And so these rates happen at sort of a fixed rate. And so he did some research, Steve Austin did, on this ocean salt acclimation. And what he found was that if you assume the modern sort of rate and the modern sort of data that we have of this, that the maximum age of the oceans will be 38 million years old, because if you start at 38 million years with 0 and then follow our current rates, you're going to get to the rate we are today. And so we're going to get to the level of saltiness we are today. And so that kind of puts a max age on the Earth at 38 million years old, which is still a lot, but nowhere compared to 4.5 billion years, which you're hearing claimed today. And the second thing of that was, he went ahead and said, okay, so I've assumed the modern rates. What if I go ahead and just take these rates and make them super minimal and essentially give the conventional geologist a hand and say, here, I'm gonna mess with some of this data that no real scientist would accept as real, but we're gonna make it super less. And he still only came up with 62 million years old, and it's how long it would take for the acclimation to take. So there's no way that the Earth is that old with the acclimation of salt in the oceans. So those are three fantastic examples of how we can kind of know the Earth isn't old. And I have a lot more too if you wanted to talk about that at the end. And so now we're going to get into sort of the creation model as we've examined and kind of said, okay, we think that the Earth is probably not old. This right here looks very confusing, and I've drawn a simpler version over here. And this is the rock record right here. It's not this simple in real life. The rocks are all jumbled. They're an absolute mess. But this is what I do, is I look at this rock record. And so, like I said, I've drawn it simple here. We have sort of 4 periods in Earth history. We have Precambrian, we have the Paleozoic, the Mesozoic, and the Cenozoic. And these main periods are broken down into all these kind of sub-periods and bigger periods, and it all moves around. This is the rock record. And so I just wanted to kind of put that in front of you, so because we're going to talk a lot about that in the next few minutes, about this is sort of the base idea of how the rock structure goes in Earth and where some things are. Just some key elements here. In the Precambrian, we don't start finding fossils in the rock record until about there, so very late in the Precambrian. This right here, the Paleozoic, we don't find a ton of fossils. Well, we do find a ton of fossils there, but not bigger things. This is a lot of ocean type stuff and ocean critters and kind of like algae and things like that. A lot of smaller life in the oceans here. The Mesozoic, that's dinosaurs, and so that's when dinosaurs take over. They don't really start till about here in the Jurassic, but the Mesozoic is the age of the dinosaurs, and then the Cenozoic is the most recent time, which we still consider ourselves in, which is the age of the mammal. When the mammals really start to take off here, this is 65 million years ago, supposedly, where dinosaurs would extinct, and then mammals take over. So that's kind of an overview of the fossil record, which we're going to get into, and how that can be analyzed. And it starts kind of with this book. So this is kind of the origin of creation science. John C. Whitcomb and Henry N. Morris. I think Henry Morris was a pastor. One of them was a pastor, and one of them just worked at the church and had a different job as well. They were both geology hobbyists, and so these guys aren't real scientists, but they had a hobby in geology. And in 1971, they published this book, The Genesis Flood. And this book was probably the first real creation research work we ever had. And the reason for that is, whenever people start putting out millions of years in evolution, you know, the Christian community hasn't done a fantastically good job throughout its history of being very reactive to this new science. We've sort of always kind of been punched by it and just sort of stepped back. A good example of that is like Galileo, whenever he proposes, oh wait, the Earth isn't actually the center of the universe. The church's instant reaction would say, you're a heretic, so we're going to kill you if you don't recant your belief. And so he did recant his belief. But the point with that being is that, you know, it wasn't until about 1971 that people really started saying, well, wait a minute, we don't just have to disregard this stuff. What if we actually start looking into it? And so they proposed the Genesis Flood as a big explanation for essentially that rock record right there, which we're going to get into. And they proposed a lot of stuff that in 2023 creation science, this book isn't really the best science that's been done. It's got some pretty crazy theories in there. But it does begin the thought process of, well, what science really could be done to begin to explain some of these things. And so look at this graph here. This is a very recent graph. This is from 2018. This graph is very confusing. You don't have to understand. I want to highlight 2 things on here, which I'll draw out actually. The first thing is geological energy. And so what I want to demonstrate, just real quick before we get started in some of these theories, I want to show kind of geologic sort of energy and how much geology is going on through Earth history. So this is like a lot of geological activity, and that's probably right at creation. And then geologic activity probably doesn't happen much until we get to the flood, and then there's massive, and then it kind of tapers off down into modern day. And that graph right there sort of shows what this is showing, sort of how geological activity should be sort of viewed throughout Earth history if you have a young Earth creationist view. And this is important for understanding kind of what we're going to look at here with the fossil record and how geologic energy should be shown in the rocks. And so one of the things that the book that I talked about, The Genesis Flood, proposed was kind of this structure, which was really a structure that I absolutely believe in. One of the biggest things they got right in this book, that in the last 40 years or so we've done a ton of work on and really kind of proven, how the fossil record structure fits into the creation view. And so it says on there, the Precambrian, which is these rocks here, is probably creation rock with some post-creation pre-flood deposits. And so that means that probably in here, most of this is rock God actually created on creation week. And then up to about here, whenever we start getting fossils, is probably some of the things that happened. Like this shows you here, this is 2,000 years of time between creation and the flood. And so there's a lot of opportunity for some rocks to form and fossils to form and some minimal things there. And then you get into the Paleozoic, which we have as flood rock, and the Mesozoic, which we have as flood. So essentially in the creation view today in geology, we view all of this rock, which is supposed to represent like close to 500 million years of Earth time in the conventional view, as happening in a year. All that rock forms in a year, and this is creation, and then this top is post-flood, so this is rock that's formed since the flood was done. And we're going to get into why we actually believe that. And so now we're going to get into the science of the flood model and how we get to this conclusion. So John Baumgartner's model and how important it is kind of revealed to us sort of the science of the flood almost. And so some of you may have heard of plate tectonics. I don't think they started teaching this in high school until not incredibly recently, but like this is a relatively new, even conventional theory, the idea of plate tectonics. And so if you don't understand what plate tectonics is we have the structure of the Earth's interior. And so you have an inner core and an outer core, and then a mantle, and then the Earth's crust. And so in this structure of Earth, what happens is this top mantle here is called the asthenosphere, and it's like a liquid magma sort of that floats, and then on that the crusts of the Earth kind of float. And so I want to show you here. It doesn't have the razor. I want to show you here kind of what this looks like. And so you've got sort of these crusts floating. And so if this is sort of oceanic crust, then you've got the continents sort of floating, and they're floating on this magma sort of here. They're these big lithospheric plates that we see. These are these plates that are mapped out kind of on this map and shown kind of here in this picture is these plates are floating on this magma. And so one of the things that we observe today in science that we see happening is this ocean crust here is basalt, and it's actually more dense than the granite that makes up the continents, which is less dense. So what happens is this basaltic crust is actually like on California, you see all the sort of volcanoes, and why we have volcanoes and mountains in the west is this ocean crust is actually going beneath the continent, and then the magma is going up and sort of lifting up this area, and you've got this sort of subduction zone is what we call it, which is shown right here in this picture. You've got the subduction zone of the oceanic crust and the continental crust, and they're subducting down, and the larger plates are sort of moving underneath each other. And when this theory happened, John Baumgartner, who here's some credentials for him, this guy is quite a scientist. He started doing some research on this. I wanted to include this quote. I think this is great. This is U.S. News and World Report, 1997, described him as the preeminent expert in the design of commuter models for geophysical convection, which is essentially that. So this was an independent, not creationist, obviously, group that basically said this guy is the expert in the world on this stuff. And so actually he did most of his work in 1994, and he started working at Los Alamos National Laboratory, which is a government-owned laboratory, computer modeling laboratory. And my professor, who knows John Baumgartner pretty well, tells the story that the government came to him and they wanted him to start working in the early 90s with their computer modeling. And so what he told them was, I'll work for you, but half my time is going to be spent on your projects and half the time I get to use for my own projects. And they said, that's fine. And he kind of used that against them, as we're going to see. And so he began doing some computer modeling, and this picture looks absolutely chaotic. It kind of is. But what I want you to start getting is there's very faint outlines of the modern continents on here. But what we have here is these bigger black outlines, which I'm actually going to show. You can see a little bit better here in the yellow, and then a lot better sort of here. And what John Baumgartner came up with the idea was, if you're not aware, conventional geology basically claims that the Earth has been in a supercontinent and kind of been spreading out throughout Earth history. And so he said, well, as a creationist, I actually like that idea. And so just kind of messing with some things, he put these continents in this view, and then he started doing some computer modeling for them. So he started taking the plate tectonics that I was talking about and started applying them to a computer model. And he's a geophysicist, so he did some physics work and came up with two key elements that led to a model which I'm going to show you in a moment. which essentially we call catastrophic plate tectonics, which is based upon an idea of runaway subduction. So what John Baumgartner proposed was that this ocean basalt at the beginning of the Earth, whenever God created it, was actually even more dense than it was today, and that this continental crust was at its original time. And so what he claimed happened was, for 2,000 years, Earth had been moving along, and God sort of almost programmed the Earth, so right around the time of the flood, whenever he needed it to happen, this crust would start to speed up in its subduction. And there's actually the physical data that's been done to kind of prove this, where when this starts subducting, the magma heats this up, which causes it to move faster and faster and faster, and so you get this runaway subduction. And what he basically proved in this computer model is that this runaway subduction can happen so fast that the ocean crust can just slide underneath the continents very, very, very suddenly, which would have massive geological results and consequences. And that's what he began to propose here. So he ran this computer model with this data, with this runaway subduction put in it. And he took this computer model and laid it out here. And this is, I think, a couple days into the experiment, basically proposing what would happen if we started this runaway subduction randomly. And what you start seeing here is this subduction, which if you're looking at these two pictures, you can kind of start to see it. And it's really kind of revolutionary. What happens is all of this blue zone kind of here and this blue zone here is where these subduction zones are happening. And then these are the continents around it. And then this is a mid-ocean ridge where the ocean itself is actually spreading, where back over here you have another plate, and then magma's coming up out of this as they spread apart into the two sides, kind of around, down into here and down into here. And what happens when you do that is, this right here, magma is just pouring up into this. And so what happens when you take a bunch of magma and you put it at the bottom of the ocean surface, and we're not talking like a volcano, we're talking like this entire strip of magma, is the ocean's gonna flash to steam, and it's gonna turn into a geyser, like you see like Old Faithful. It's gonna turn into an absolutely massive geyser, which would cause the entire atmosphere to just have a ton of water vapor, which would create an opportunity, if this continued to create a geyser for several days and for weeks, would create perpetual rain throughout the Earth, which could last for days, essentially. And so that's the first thing that he proposed. But the bigger deal here is when you think about it, rain covering the entire continents. That sounds absolutely crazy. This is one of the things I struggled with before I came to Cedarville, was how do we get enough rain to cover Mount Everest? I mean, that's just absolutely crazy. Genesis tells us it covered all the mountains that I just saw right here. Genesis 7:19, they rose greatly on the earth, and all the high mountains under the heavens were covered. And so you got to cover everything. How does that happen? And the answer is this right here, essentially. When this convection happens, this basalt, which is originally denser than this continental crust, so the continental crust stays floated up, this is now turning into magma, and so it becomes less dense, or it becomes more dense, and this becomes less dense in relation. And so what actually happens to cover the continents, which you can see, where did I put my clicker at? In these two pictures here, as you go back and forth, is the continents start to spread apart, and actually the continental crust here and the oceanic crust here actually level out. And so the entire world gets covered in a flood. And it's not because of rain, it's because the entire continent is almost moved down. And so that's just an incredible model that he proved. Obviously, at this point, it's just a model, it's just an idea, so it's not absolutely proven until we can do some more research on it, which we've done, and really back this up. And this is kind of where it leads. You can start to see the continent separating. This is 25 days in, and you can see the continent separated, the entire Earth is covered. You've got this increased magma going on here, and this massive geological energy, which I think is a great example. I mean, the geysers to me is literally the fountains of the great deep opening up. That's exactly what's happening. That's what Genesis is telling us. And so when I heard this, I was just thrilled, and that's why I'm so excited to show you about this idea of the continents literally go. And then you kind of say, well, I didn't really put this in here, but how does it fix itself? Well, eventually this basalt is going to cool down because it's in water, and this loop is going to continue. Once all this basalt is down, it's going to stop. And so this is going to cool down, and then they'll just kind of float back up, and then you solve the whole problem, and the entire Earth is unflooded, basically. And so it's a great model, and the real big seller for it, the really big deal about the whole thing was John Baumgartner proposed this, and in his model, you can't see it here, he actually did some interior earth scans too and predictions on it. And what he found was that these slabs of cold basalt would kind of float down and sit on the edge of the mantle in the outer core. And in the early 2000s, a non-creation research, an actual like a governmental research agency, was doing some work with earthquake waves and studying the interior of the earth, and discovered on both sides, like you would see in this kind of one over here and one over here, one over here. They discovered down up by on the boundary of the outer core of the mantle, two massive kind of anomalies of cold mass down at the bottom of the mantle, which would essentially be these plates. And they said, well, that shouldn't be there, because if the Earth is millions of years old, like we think, those things should have cooled or warmed up by then, and we shouldn't have these anomalies here. Why are they there? And it's like, well, I can tell you why, because 4,000 years ago, they sank into the thing, and 4,000 years in geological time is not enough to cool them down. And so that's a perfect kind of, once a model like this can do something and predict something without just claiming it and just sort of predict it and then it comes true, that's fantastic evidence for that model, because he didn't bias it at all. It just kind of happened, and he's like, oh wow, that's great evidence for a model. So that's fantastic evidence for this CPT model, which is essentially what I proposed to you today as why the flood happened. So now we're going to get into this rock record right here and how this gets out. This guy is a random guy, I don't know who he is. It's just a picture. And this is talking about the great unconformity. So what you see here before you is essentially two rocks here. As a non-geologist, they might not look like a huge difference here, but this right here is this Precambrian rock down there at the bottom. This is actually metamorphic rock. It's Vishnu schist. And so this rock right here is sort of what we propose as created rock or pre-flood rock. And then this right here is an unconformity, which is essentially kind of a boundary between two different rock layers at a weird level. And this right here is sandstone, which is something that forms in a sedimentary environment. It's a sedimentary rock, something that would form in a massive flood at the bottom of it. And so this great unconformity is a really big deal, because you find this everywhere throughout the entire world. And you find this great unconformity usually somewhere here at the top of the Precambrian and the Cambrian, which is the first part of this Paleozoic. And so this, no matter who you are in conventional creation, this great unconformity is just recognized in the rock record everywhere throughout the world. And why it's such a big deal here for us as creationists is for two reasons. Well, one, in the original view, the Vishnu schist is 1,750 million years old. And the Tapete sandstone, which we find not called the Tapete sandstone, but called other names, but basically the same sandstone throughout the entire world above this, is only 525 million years old. So you have an unconformity here. You have a gap of 1,225 million years of time represented, and these rocks right here that just sort of disappear. And that's pretty common in geology, but this is the biggest example of it, and that's a massive problem for conventional science, because where's all the time gone? And for us, or for me as a creationist, I look at this, and what I see is just the start of the flood. The flood has literally eroded everything, and that's why you've got this unconformity everywhere. And then it just starts laying down rock itself. The flood does, right on top of it. We have sandstone. I hadn't noticed this until right now. Very technical feature. There's cross beds in here that you can very loosely see. And that's a great example of cross beds that would form in a sandstone that's underwater in a marine environment. And so this right here is just a fantastic example of rock forming after the flood, and the flood itself being kind of leaving behind its trace. Here's an outline of the Tapete sandstone in the United States. And like I said, we don't call it the Tapetes everywhere, but we find similar sandstones like this on every single continent except for Antarctica, Antarctica is really weird. It just is. But other than that, the other 6 have this Tapete sandstone. And so that's exactly what I was showing right here. This Tapete sandstone is right here at the base of the Cambrian that we find throughout the world, which I propose is the original flood rock. And now we get into fossils and the fun about fossils. And so the Green River Formation is actually it's a formation in Utah and some in Colorado and I think in another state. And it starts, it's a formation that we find here in this early Cenozoic. And so now we've kind of moved to after the flood, which we'll get to why. And so the Green River Formation is a formation that Dr. Whitmore, my senior professor of geology, did his PhD on. And what he found, his dissertation, what he found was some astounding evidence. And so in the Green River Formation, you get these sedimentary layers in this oil shale is what it's called. This is a pretty pretty standard geological formation. And you see these layers, and these are called in conventional geology is varves. Each layer is supposed to represent a year of geological time. A year has gone by, and then it keeps forming up on top of itself. And there's two things that Dr. Whitmore found in the Green River Formation that are really, really good evidence for why each one of those is not years, that formation, which while it's after the flood, is a catastrophic example of how rock can form really fast, and how fossils can form really fast, which then we can apply to the flood itself in these other time periods. And so right here's a fish fossil. That's essentially, we find this fish fossil stuck in between two of these layers. And the big problem with that is that he found is that if that represents a year of time, and this is really bizarre, but Dr. Whitmore considers himself, and I consider him, the leading expert on fish decay in the world. And so he did like 2 years worth of studies putting fish in tubes and watching them decay and see how fast they would. And he found that any fish that sits in water for longer than a week, there's actually a swim bladder in here which has like gases that build up in it. And so you'll find pictures, I should have included one, where this skeleton actually like blows open because the swim bladder breaks open in like a week at the most time. And so in order for this fish to have been preserved in this state, it would have had to have been buried and wrapped within like a week's time, just really fast in terms of geology. And so this is astounding evidence because it shows we can see how modern or conventional sort of geology would point to something and say this fossil must take lots of time to form and slow sedimentation, and these varves are a year. And he goes, no, this is very, very fast. And the second thing is this picture right here, which is a sort of a broader view of these varves, these layers in the oil shale of the Green River Formation. You have two sort of black lines here that are actually, they're almost yellow in real life, but they're definitely a different color. And what they are is they're volcanic ash beds, which sort of lay throughout this Green River Formation. And this is another big deal because when you think about volcanic ash, if a volcano erupts and then lays ash down, and then rock piles up on it, and then it lays it down again, all the rocks that are underneath that and just above that, like they have to form in a specific time in relation to those two things. Like the time in between these two things, it can't change because this volcanic ash forms at a fixed point, right? And so we know like this volcanic ash couldn't have laid down here and then this builds itself up and then it lays, like there's no way for volcanic ash to not happen instantaneously. And so what has to happen is this ash bed is laid down and then these layers and then this ash bed and then these layers. And the reason why that's a big deal is because if you follow these ash beds throughout the Green River Formation, you find that the amount of varves in between them actually changes. And so the time, while we know that this is at a fixed point and this is at a fixed point, the time in between changes, which just isn't possible if these varves are a year each. And so that just kind of proves how these varves are not lots of years in time. They're happening really quickly and they're forming very suddenly. And that's a good example of sort of how fossilization happens. And now we're going to get into evolution. It's sort of my last sort of talk. We're going to talk about dinosaurs and all the fun critters of the world. And so this is something that I've done a lot of thought on in talking about evolution. And the big thing, you've probably seen a tree of life like this, sort of an example of how everything has evolved from this original common ancestor. And there's some interesting things here where creation has typically just kind of pushed evolution aside and say, we don't like that, we don't like that. And the thing that modern creation scientists have really started to example is the problem with evolution is time, not necessarily evolution. When you read this, I want to clarify something first of all. We do have another problem with evolution, which is we know humans are made in God's image, right? We know that we didn't evolve from monkeys and apes. And so there's no way that we're going to sit here and ever try to fit into an evolution that we've evolved. And we also have the problem with the time, right? Because we have, as we take the Bible to mean literally, with the 6-day creation, that we've got to have a time frame here that's not a lot of time. But other than that, there's no reason why the Bible necessarily specifically says, well, things can't change over time. The difference is evolution as a broad theory sort of proposes lots of time, like we saw with Lyell and Hutton and Darwin, and that's exactly what the problem is. It's all about time. It's not about change in species. We see change in species all the time. You think about dog breeding and throughout human history. I mean, we've literally forced dogs to change into so many different kinds just in a few generations with some knowledge, right? We have a human ability to influence that. And so that's kind of an example of how things and species can change very quickly. And so I wanted to read this because this is really key. these are some different quotes, or different parts of Genesis, highlighting the idea of kind. And so it says here in Genesis 6:19-21, you were to bring in the ark 2 of all living creatures, male and female, to keep them alive with you. You are to take every kind of food that is to be eaten and stored away as food for you and for them. And then another passage, Genesis 7:2-4, take with you 7 pairs of every kind of clean animal, a male and its mates, and its mate, one pair of every kind of unclean animal, a male and its mate, and also 7 pairs of every kind of bird, male and female, to keep their various kinds alive throughout the earth. And then it says down here in Genesis 7:14-16, they had with them every wild animal according to its kind, all livestock according to their kind, every creature that moves along the ground according to its kind, and every bird according to its kind. And that sounds like it's kind of just like, why am I highlighting kind so much here? And essentially the thing is here that creation science has looked into, and some of the Hebrew of this as well, because the word kind isn't necessarily meaning species. It's saying kind I want to see what's on my next slide here. Yes, I want to highlight this. In taxonomy today, in zoology, we have these different animals, and we have different classifications of how we classify things, and this is largely from evolution. We take things and group them into groups. And so when you look at different species, they have different names. So like mammals, we are in a kingdom, we're in a phylum, we're in a class, or a kingdom, phylum, anyways, order, family, generic, species. So we're in this structure of sort of taxonomy. And when you look at the ark and think about all the things that he's saying, you got to get all this stuff on the ark. And you think about birds, for instance. In modern time right now, we have identified and named and labeled and specified 10,824 species of birds, which means in this Genesis account right here, as you say, it says, and also 7 pairs of every kind of bird. So that's 14 of every bird. So if you do the species math, that's 151,000 birds that are supposed to get on the ark. That's 31,000 birds if you're looking at the genera level, or 3,000 birds at the family level. With arthropods, I didn't even attempt to mention the lower levels. We have basically almost a million. Arthropods are like insects and trilobites, if you've ever heard of them, and crabs and stuff like that, these kind of critters. We've identified almost over a million species at this point of these arthropods, and so if you're getting a pair of every single one of them, that's absolutely insane. Mammals ourselves, we have 5,900 species with 1,258 genera, 156 families, 28 orders. And so the point is, when you're sitting there in your creation science looking at this ark and you say, well, unless something supernatural is happening, we don't know how we're getting all these things on the ark. And that's what we say as scientists. We go, well, we don't want to assume the supernatural because obviously God could have just snapped his fingers and it works because he's God. But we want to see if we can find a science to sort of explain that. And so we've come up with baraminology, which is, it actually means, baraminology means the study of created kinds. And so this is a really big deal. And what this has been doing, if you've been to the Ark with Answers in Genesis, down in, it's either Ohio or Kentucky, I can't remember. Kentucky. If you've been there, they really propose this idea, essentially, of baramins, which are created kinds. When the Genesis account says kinds, it's referring to almost sort of a subgroup. And that sound, in a Christian sort of community, it sounds crazy to say things have evolved. But I really don't think it is, because you've got so much time here. You've got 2,000 years leading up to the flood. And since the flood has happened and these things have got the ark, you've got 4,000 years of time represented, which is a lot of time, if we're being honest, when you really think about it. In terms of like geology or conventional geology, it's no time at all. But when you really think about it, 4,000 years is a lot of time when you think about how quickly we could have bred dogs. And so essentially what's kind of been proposed today is that we have these created kinds. So for instance, my best example is like cats. We have like lions and tigers and things like that. It sounds crazy, but what was sort of been proposed is that there's probably an original cat species that was on the ark, a pair of those two, and then if they reproduce and spread throughout the earth, and if you're a cat and you're in the Sahara of Africa, you need to be bigger and stronger, and there's much different needs than if you're in another place like a snow leopard in a colder climate where you have to be white would be a thing. And so these are small little changes. We're not suggesting that things have necessarily like evolved one from the other. Like you can see in here how it's not like these two things are all related, but that they've sort of speciated out of each other. And we typically use the family level. So like an example of a family is the cat family. The Phaladia is a family. And so that's essentially what's been proposed to kind of fit these things in the ark, is that there's actually maybe more evolution than we're kind of willing to admit. And like I said, it's kind of a crazy idea, but I really don't have a problem with it personally. I actually really like it because we can see things changing. I mean, Darwin's finches are very true. Like, you see them change all the time and then go back and do all these things. And it's not necessarily that they're evolving from one thing to another, but they are changing, and it's all about the time, like I said. And so if you're not proposing a massive change in an organism or a massive change in, you know, anything structurally, just some minor tweaks in kind of physiology. I mean, you think about the variation in humans ourselves, right? We haven't changed species, and we know that because God has kind of kept us sacred and we're created in His image. But there's still massive variation throughout the earth of what humans look like. And it's just small subtleties like that that could really lead to kind of all the species we have. And so that leads us to kind of the final point, which is like one of my favorite topics, dinosaurs. And so what do we do with dinosaurs? And because we have fossils of them, and it's like if you listen to a conventional scientist, dinosaurs and humans didn't exist together. That's a preposterous idea. And I'm here to tell you today that I think dinosaurs did exist. I've heard some people who just try to kind of explain them away, and I say, I think dinosaurs definitively exist, and I think we probably existed on this earth together, and I think that they grew in prominence and size. When the fall happened, I think the dinosaurs kind of took off, and I think that it says the earth had become violent and evil. This next picture, if that's not violent and evil, I don't know what is. And so I think that that's probably something that might not have, Moses is writing this, and he's maybe not trying to be super literal and everything, but that's something that could be kind of fitting into the pages, right, is this idea of we've got these evil things that have sort of happened, and God sort of uses almost the flood as a way to kill them. The problem, however, is it's not that simple because it says one of every created kind, and so, you know, you've got to have dinosaur kinds on there. It doesn't say He just excluded some because they were bad. And so, I want to see what's next, okay. The thing that's interesting that we've kind of proposed is that it's really almost more climate. And so I don't have a slide in here. In retrospect, I should have put one. An interesting thing that's been proposed in the last 30 years or so that I am a huge subscriber in is an ice age after the flood. And so all the magma that I was talking about in the flood and the runaway subduction model, the interesting thing about that is that's going to cause the oceans to be warm. And if you know about climate, you know that when you warm up the oceans, that creates an ice age just like that. I mean, because then the moisture is evaporating much easier, and so in the poles where it's colder, there's much more moisture, and so it just starts snowing indefinitely, and that's exactly what forms an ice age. And so that's kind of what we propose is in some time here after the flood, in this kind of 1,000-year window here, there's an ice age that almost happens, and dinosaurs like that would not be fit to survive an ice age very well. And also another thing that happens too that's very interesting in this fossil record, and look at it, and it is throughout all of time here, the predominant plant species are gymnosperms, which is it's a technical kind of idea. But the opposition, sort of the other big player in the Cenozoic is angiosperms, which are flowering plants, which is what we see in massive abundance in our own lives. Like, for instance, grass is a fantastic example. Grass is an angiosperm, and it's very prevalent throughout everywhere you go in the earth. Now, we don't find grass anywhere in the fossil record. Like, you just don't find grass in any of these rocks. And so that's not to say it didn't exist, but the idea essentially is, you know, with fossils, just because it's not there doesn't mean it didn't exist. It's not like fossils just are like a camera. They don't capture everything. They capture some, though. And so kind of an idea sort of is that what the earth looks like here and what the earth looks like here after the flood are two radically different things, where God sort of almost is correcting all the chaos that's happened in those 2,000 years of violence and changing it, sort of using the flood as a model, or not as a model, but as a mechanism to sort of create this change and get this turnover. And that's another big proponent of why dinosaurs went extinct, because it's like that this guy here eats massive herbivores, like this thing right here. This is a triceratops, which we look at compared to a human. That thing is huge. That's a herbivore, and so that's got to eat things, and it's got to eat plants, and it would likely be fed on gymnosperms. And if gymnosperms, basically, they don't go extinct. We have them today, but we have a way less variety of them. If those aren't readily available for him to eat, then he doesn't have anything to eat, and they all just kind of die. And then the colder weather as well is a big problem for large reptiles like that. And so pretty quickly, it's a great explanation of how you can get rid of dinosaurs while also having them. And so that's essentially how I would talk about dinosaurs. And the last topic, I believe, yes. The last topic is human evolution. And I want to address this. Like I said, I don't believe in any human evolution at all. But what you will see proposed here is you'll probably see this is a picture of Lucy, a fossil that we kind of have, and you'll hear a lot of talk about, or like Neanderthals or lesser humans, or this is actually called an Australopithecus. And what these things are talking about is fossils that we find, particularly up in here in this fossil record of, you know, human-like ape type things, and it's sort of suggesting human evolution. And the main thing that I want to point out is the fossil record of these things is absolutely horrendous. That's not to say that the Mesozoic or Paleozoic fossil records are great. I mean, you can't imagine how difficult it is to piece this stuff together. It's terrible. But like the Tyrannosaurus fossils, you've seen things like, well, Tyrannosaurus rex is one of the most well-preserved things we have, but a lot of dinosaur fossils are so, like this image is very unlikely that it looked like that. It could have been, it's probably similar, but like very different at the same time. We have no real idea. We're just piecing together from bones. And so the fossil record is chaotic, but like human evolution fossil record is so much worse. That entire picture that they've got right here, this is every actual bone fragment that they've got from Lucy, that they actually have. And not only that, some of these, like you can't actually see, but some of these are like little fragments that they piece together to say, well, that might be an arm or something. And so it's, and this is probably one of the best preserved we actually have of anything like this. So it's an absolute disaster, and then try to claim it looks like that is pretty crazy. And the reason why I highlight this is because is the second thing is, well, one of the base things that we proposed is when you look at this and you say, well, that's not very complete. But even if it is, we still know that thing is pretty small. And we find a lot of smaller ape-like things kind of earlier in the thing. And personally, I think this might just be an actual human. We have no reason to assume that humans here before the flood, I mean, 6,000 years, you can see the variation in humans today. We don't know what the original humans looked like. I'm sure they looked similar to us, very similar to us, but their height or some of their like structures might have loosely changed throughout time, because you can see it in our own world today. I mean, you go to different continents and you've got smaller people in some continents and larger body structure, and it just sort of happens. And so there's no reason to say, well, we just dug up a very small, or another great example, this could be a kid. This could be, you know, we don't have any idea of how these things, whether this was a male or a female or a kid or whatever, we don't have live representation. They've assumed from what they see there that this is a female adult ape, but I mean, we have no real idea of knowing whether it is or not. And so that's just some great things if you're talking to someone who's really a proponent of, hey, you know, we've got human evolution and here's evidence for it. It's like, it's not really evidence, that's just sort of you fitting something into a model because you want to. And that's really all I've got. I hope that that's helpful. So, yeah.
Wow.
Thank you guys, appreciate it.
Awesome.
I have a question.
Of
I
course.
want to know who the people are that you came with you.
The people that came with me,
Yeah.
okay, well, this guy right here.
I'm Dad.
That's my dad. That's my mom.
That's what I thought.
And
Thank
then
you.
next to my mom is my youngest brother.
Okay,
And then behind him is my middle brother.
okay,
So that's my family. And my aunt's back there too.
Yeah.
okay.
That's my family. Yeah. That's me. And this is up here. Please contact me if you ever want to, or talk to me anytime the rest of the day about this stuff. I'd love to.
Thank you.
Great job. Wow.
Yeah.
You are so knowledgeable.
I got a question.
Yeah.
Have you heard about the hydroplate theory? No? Okay. It's interesting, look into it.
Okay.
Yeah.
Absolutely. Yeah. I would love to. Yes.
There's another thing, who created time?
Created time.
Yeah. God,
God. Yeah.
so time will, you know, we know it, time will stop because it says that time will be no more.
Yeah.
So he had to create it. So when we look at it, well, how do we put it in time when we don't know when time was created?
That's a very fair point. That's a fantastic point. Yeah.
Another thing I was wondering is, how does all this that you've taught us this morning relate to the present controversy of climate change
Oh,
that
yes.
we're experiencing? People say we're experiencing, put it that way.
That's a great question. So there's a ton of opinions on this, and you're gonna get other opinions. For me, one of the interesting things is the warmest period of time that we have is usually represented right before this ice age that we propose here, and in this late Mesozoic is what the conventional community will propose. Creationists will usually say that probably was some of the things that we see in the plants and animals, probably in this late Precambrian, like before the flood happened, so about here in time, it's probably pretty warm. And so there's a lot of talk about climate change, and in terms of whether that would be a massive travesty for Earth, likely not. But in terms of, one of the things that I've been in a lot of science classes, one of the things that is a big impact though is species throughout the world. And so climate change is a really bad thing for a lot of ocean organisms in particular, particularly northern ocean organisms. And so it's not so much that climate change would be a massive issue for humans, but for a lot of other species throughout the Earth, it could be a big deal. Also, if we warmed the Earth too much, we could ice age ourselves. Like I said, we could get the oceans too warm. The oceans are warming slightly, and so if we did that enough, then you could ice age ourselves like happened after the flood. It would probably be somewhat difficult, but it's possible. So that would be another problem. If you don't like cold like me,
Okay, when did creatures turn bad? I mean, like, okay, like I don't like mosquitoes at all.
oh yeah.
I mean, were they always, I would say, bad, or when did they turn bad? You know what I mean?
Yeah, I do. That's a very tough question, because there's not a lot of sort of talk on that, and also a lot of the stuff that we're reviewing for these past things is just fossils, and so it's like, we just have the bones of it. But, I mean, the Bible says the fall creates violence, and so
Okay.
I assume that we're getting somewhere in this earlier time, you're starting to see things changing for the worse, and
Okay.
things. Also, I have no idea what the fossil record says on the
I
site.
just blame it on Eve.
Yeah.
Well, you know, maybe that kind of goes back to a little bit too, like we got with the fall, you know, things changed with the fall, and not just in terms of humans and our relationship, but also the earth. You know, there was a kind of a curse that kind of happened with that too. You know, we had thorns and thistles, and the Bible talks about that. That like work wasn't in the garden. You know, before the fall was like a perfect work environment. And work was actually a different word, like that's a word for work. Originally, before, it's a different work that was then now, and you know, and we talk about that in Genesis. It talks about how things changed after the fall, only for man, and we would toil and we would work with our hands and we would fight against it. I think that also applies to like creatures, like there's this, because all creation is a yearning to get back to, or to get to that, you know, that final Sabbath of when things are not like, they're not as they should be. Things are not as they should be, whether it's insects, whether it's animals, whether it's the earth, you know, and the ground. I think all those things are yearning to get back. So there is things that have happened since the fall, that it's not just us that have been changed in terms of like we have sin now, but also I think the creation has that sin and that problem too, that it's waiting to be redeemed back to where God wants it to be. So I think maybe that's part of that. It's more than just geology. I think that's also part of that answer too, not the whole answer.
Yes.
So you did a good job, I think, of laying out like there's multiple views on this.
Yeah.
How do you recommend, or what would you encourage us to engage with people? Because as a church, we're not all going to view this the same.
No.
So how are you, and how should we be engaging with people of all different perspectives on this?
I think that one of the key things is that it's not like this is right or die stuff. Like, I'm just researching and listening to people around me and hearing what I think is the best science. But I mean, if I'm wrong, it doesn't mean that Jesus just is like, oh, you don't count now because your science was wrong. So that's part of it, just kind of having a discussion and being willing to be like, well, we don't have to both agree on this necessarily to be in community. And the other thing is too, like I said, we don't have to run from science. I really like this as just sort of a thing for someone who's really struggling. I'm around a lot of young people, and Cedarville's a little bit different, but who they've gone to school in their entire life. It's just sort of like the science just says this Bible is just not real. And so for me, the thing is, it's like, well, it's not so much trying to convince them with it, but just say, hey, open your mind to the possibility. Maybe there's some science that says this is more plausible than you think, and then they can actually get to the hard issue instead of just blocking that with science. So that's it.
Thank you.
But I mean, you just got conversation.
I like what Spencer said at the beginning, which was that it's not that Time article says it like God versus science. I think that point was really huge. That like it's not God versus science, and actually science can be argued. Like if you want to talk about, you know, God versus there's no God, you know, being atheistic, for instance, or agnostic for that matter, science could be used to argue for either. So science is not against science can be used for either way. And here we're saying science supports the idea of creation. And if got so science is being used for that point. So I think when you engage with people, I think maybe this might be part of my thought process, maybe not a complete answer to what you're saying, Ross, is that we can then engage with people and say, I don't think that like what you and I are saying is necessarily in complete contrast to each other. We're just looking at the facts from a different point of view, and we can invest and we can listen to each other, we can engage in the conversation saying that we believe in creationism, but we don't have all the science to get there. I mean, we're never going to get there. We're never going to be able to prove because there's this thing called faith. And there's this thing called God is God and we are not. So we can't fully understand and figure out and prove these things. So we come to it from that standpoint and we engage in the conversation saying that like, we're not actually so far opposed to you in every way that you think. We're just using this science and what we know as a way to say, here's what our explanation is from a faith point of view and from a supernatural point of view. So, and Spencer said at the beginning, like the whole supernatural part, he was saying we're not looking at it as part of like from a science standpoint, we're trying to like prove what we can actually prove because from that standpoint, I don't know, that's part of an answer I tried. Yeah.
Well, science is about reproducibility.
Right, yeah.
And science is constantly changing. And so the more we know, the more we can have reasonable conversations. And I think that's the big thing about science. You know, science isn't this magic box that I bring out to prove this or prove that. It's like, this is what we know to our best knowledge right now, and this is what we don't know. And so let's talk about what we know, and let's come to a intelligent decision.
Yeah, I didn't talk about this stuff is not without flaw. We got a lot of problems working through that. Like, I don't know. Like, best example, it says it killed every human being on Earth. We have no human fossils until like the top of that thing. So it's like, why is that? Just stuff like that. So.
But also too, we have like going to like the point too, and going back to that well, is like there's been in the last few decades, we have the combination of like technology and being able to study things, tools for that like never before exponentially, and the discovery scientifically that happened that support creationism, as we talked about, like it's an immense amount of stuff that's been happening, but you don't hear about that in the mainstream news. So the average person you talk to, they probably have not heard of a lot of the things that actually like Spencer's learned about and other things. If you dig into it and you read some of these articles, things like, it's amazing the things that are being studied and being found out, and science is now discovering that has never happened before by any comparison compared to what we've had in the last, let's say 30, 40 years, or even like the one guy you had up there from like 1997, John Baumgartner, is that the one you were talking about? Yeah, yeah. So that's, anyways, there's just been so much that's been happening, but you don't hear about that. So maybe the other person says, maybe this is a good way to encourage them. I'm sorry, I keep going back to your question, Ross, because I think that's really important. Like, just encourage people to like, did you ever think about looking into this as a different way to look at it and like looking into what actually has been discovered in recent decades? It's worth looking into.
Thank you.
Yeah, thank you very much.
Thank you very much, Spencer. It's great to know that young people are taking to church with knowledge like that.
Amen.
And that you're going to really make an impact. By the way, are you planning on a doctorate and so forth?
That's a great question. I'm planning on going to seminary after.
Oh,
Yes.
that's a better thing.
Yeah.
But there is a likely chance that at some point down the road I will want to get a doctorate and stuff. We'll find out.
Well, we're proud of you as far as a person from our church that's
Yeah.
continuing will take the gospel to the world like that with knowledge. That's a really neat thing. All right, hey, I guess it's probably need to get into the sanctuary sometime today. So I think we'll release the group now. And thank you so much for coming. That was very interesting.